Hey guys, today I couldn't be with you, but you have a substitute, but you are to be listening to me as we go through this video, and you are to be taking some notes. So take a couple of minutes while I introduce the topic to get out a piece of paper. Um, Mr. and Mrs. Substitute, if you could please pause anytime you need to. We're starting a new chapter today all about matrices. If you've seen the matrix, it's slightly related. You were introduced to matrices last year in Algebra 1 if you were in Baltimore County, but if not, I think you'll catch on pretty quickly. Matrices are used in higher mathematics to help organize information and for making tedious operations a lot easier. You may not see the benefits of matrices right now, but if you take a higher math class after Algebra 2, you'll see it, and if not, maybe you'll just find them interesting. It is a slightly easier chapter. There's not quite as much algebra involved, so I think some of you might just really like it. We're going to start by looking at the structure of a matrix, okay? So if you have some paper, don't forget, and then we're going to move on. My toolbar is in the wrong spot. I just can't get everything in its place right now. There we go. Okay. So I want you to take a look at this and write down this picture right here of a matrix. And I want you to use this vocabulary here to label the parts. What is a row? What is the matrix? What is the dimensions? What is the column? Okay, take a few minutes to do so. Okay, so the whole thing is the matrix. All right, so we're going to just draw a circle around the entire thing is the matrix. The dimensions are how big or small the matrix is, and we'll talk about that back in a second. A row, this is a row going across. We have 1, 2, 3 rows. Columns are going up and down. Just like on a house, you can see columns on the front porch, or in Roman or Greek architecture. The element is one piece of the matrix. There are 6 elements, and sometimes we call them cells. A zero matrix is actually just that. It is a matrix with all zeros in them. A row matrix looks just like that. It is one row. A column matrix, is a column. And a square matrix looks just like a square. It has the same number of rows as it does columns. This is a square matrix here. This is not a square matrix because it has 3 rows and 2 columns. Okay? So let's look at a couple and look at their dimensions. On the last one, we had this matrix. Our dimensions, we write something by something. And the first blank is our rows, and the second blank is our columns. And I'm all old school, and I remember RC Cola. And that's how I remember the order, the R and the C, RC Cola. It's a drink that was a lot like Coca-Cola. I'm not sure which came first. Probably Coke, I think. So this particular one, there are 2 rows. So we would put a 2 here. And there are 3 columns. So we're going to put a 3 here. So this is a 2 by 3 matrix, its dimensions or its size is a 2 by 3. How about this one? What would we call this one? The dimensions are, yep, that's right, a 3 by 3. Very good. Okay, so that's the simple pieces of a matrix. So now I want to take a look at some things that a matrix helps you figure out. Some of these are equivalent matrices, and some of them are not. Okay? Take a look, work with your partner to figure out what an equal matrix has to have and what an equal matrix does not have to have. And coverage teacher, if you could pause for a couple of minutes to let them talk. Okay, so what did you say an equal matrix has to have? Or what do these have what's wrong with these that make them not equal matrices? Okay, so this first one, they don't have the same rows and columns. This one is a 3 by 2, and this is a 2 by 3. So they don't have the same dimensions. They have the same numbers in them, though. They look kind of equal if you turn it on the side, but they're not equal because they don't have the same dimensions. Look at these. They have the same dimensions. They're both 2 by 2s. Why do you think these two are not equal matrices? They have all the same numbers, but you're right. They don't have the same numbers in the same places. They're not in the same position. Good. So now the one that says equal, does it have all of the right stuff? Do they both have the same dimensions? This is a 3 by 3 and a 3 by 3. And do they have the same exact cell in the same exact positions? 560, 560, 072, 072, and 314, 314. Good. Okay. So equal matrices are very useful because look what we can do with them. Using the idea of equal matrices, work with your neighbor next to you to see if you can figure out the missing pieces. Solve for x and solve for y. But keep in mind that this piece right here is one cell. The x plus 4 takes up one cell, and this is one cell. 2y is one cell, and 12 is one cell. That might help you a little bit. I'll give you a couple of minutes to work with the partner either across from you or right next to you. Okay, so did we figure out what x is up here? If these have to be equal matrices, then they have to have the same dimensions and they have to have the same cells in the same exact places. So this one over here looks really easy. This is 9 and 12. This is a 2 by 1 matrix. So this has to be a 2 by 1 matrix also. And if you look what I underlined, this cell right here is supposed to equal this cell. So I can take it out of context and write x plus 4 is supposed to equal 9. So what does x have to equal? That's right, 5. So x is equal to 5. And what does y equal? Well, if I take it out of the context of the matrix and I write 2y is equal to 12, then y should equal 6. Good. In the other problems, this cell is equal to this cell right here. So x plus 2y is equal to 9. This looks fancy. And then 13 is supposed to equal 4x plus 1. That looks like a system. We just took a test on systems. Take a couple minutes to solve that system. Okay, so you should have gotten x was a little easier because I could just subtract 1 here and subtract 1 here. and I get 4x is equal to 12, and then x equals 3. And then I could take the 3 back up into this and substitute 3 plus 2y is equal to 9. So 2y is equal to, subtract 3, so 2y equals 6. So y is also equal to 3. So you should have gotten 3, 3 for that one. And this one, this is a true system with 2 variables and 2 equations. So you should have done, you should do either substitution or elimination on this one. Okay? Okay, so for that one, you should have gotten x to be 2 and y to be negative 5. If you didn't get that, you need to check with the neighbor to see what your math. Okay, but I would have set it up to look like this. X plus 3y is equal to negative 13, and 3x plus y is equal to 1. And then I multiplied the top equation by a negative 3 and went from there. See what you can do to make sure you get the right answers. Okay? But we're going to move on a little bit. I'm not as concerned with the algebra as you are with understanding what you're supposed to do to solve it a little bit today. Okay? So that's the end of this video. I'm going to stop this one, give you guys a couple of seconds to take it, re-look at your notes. We talked about a matrix, the rows, the columns, the dimensions. We talked about equal matrices, and then we looked at how equal matrices can help us solve things.